All right, so we talked about this before. Let's just go over it because I want to do a more challenging one on this one. So 16 minus x squared, you know it crosses at -4 and 4, but the rectangle that's inscribed doesn't touch those coordinates, right? It's inside. So it's like somewhere here. And so that's going to be an x value, and that's going to be an x value. So your width will be 2x. Because we want to find the largest area. So you know that area is width times height. Okay, so let's go check out what the height will be. So this will be the height, and that's going to be the y value, right? So the y value is that quantity. Okay, so I have area is 2x times 16 minus x squared. Absolutely multiply this out. Minus 2x cubed. Before you take the derivative, since it's want the largest area, you know you need to take the derivative of the area and set it equal to 0. So a prime will give you 32 minus 6x squared. Set that equal to 0. And you get 32 is 6x squared. And then divide through, you get 32 divided by 6 is x squared. So that's the same as saying 16 divided by 3 is x squared. So x will equal plus and minus 4 over root 3. Okay, so that's it's going to help us find the width, right? So the width will be 2 of these, right? 2 of those x values. So 2, 4 over root 3, right? In both directions. Okay, so then how do we find the height? The height is going to be the y value at that x value. So I get 16 minus 16 thirds, right? So that would give so y is equal to 32 thirds. Okay, so there we have it. The width and the height, right, that gives us the area of the biggest rectangle. Okay, this one here is much more challenging. So let's just be careful with the algebra because that's what makes it more challenging, not necessarily the problem. So this is saying underneath here, between -4 and 4, right, because you know that's a half circle with radius 4, I want to find the rectangle that's inscribed, so very similar, right? So you know this is an x direction, that's an x direction, so the width of my rectangle is 2x. Okay, so what's the height of my rectangle? The height of the rectangle is y. Just one y value, right? So I want to find the largest area. So I want to find the area equation and again take the derivative of area and set it equal to 0. Okay, so area will be 2x times y. So whoops, and so area is 2x, and then the y is this. Ooh, this is going to be a more challenging derivative. So for sure we have to do product rule. So first, d second. Okay, so this right here is an easy thing to forget. Don't forget that, right? So 16 minus x squared. And then times the derivative of the inside, right? Plus second d first. All right, so now we want to fix this up. So I can see these twos cancel. And then I have an x and a -2x, so 0 equals, so that's going to give me a -2x squared, and I want to encourage you to move this negative exponent guy to the denominator. Good? Okay, so then continuing on, plus 2 times square root 16 minus x squared. We've got it equal to 0 because that's what we're trying to find the critical numbers of. So let's move this to the other side of the equation. So I get 2x squared, 16 minus x squared is equal to 2, 16 minus x squared. So I see I can cancel the 2's. And then I'm going to multiply both sides by 16 minus x squared. 16 minus x squared. So these cancel. So I'm left with x squared equals, and when you multiply these two, you get 16 minus x squared. All right, let's solve for the x. So I get 2x squared is 16, x squared is 8, and so then I get x is equal to plus or minus root 8. So what was I doing again? Oh yeah, I want to find the width of my rectangle, right? So I can see the width of my rectangle will be 2 root 8, right? Because there's positive root 8, negative root 8, so that's the width of my rectangle. So how do I find the height of my rectangle? The height of my rectangle is the y value. So that's going to be putting in root 8 into here, right? So I get square root 16 minus, oh, wait a minute, I'm squaring it, right? So 16 minus 8, and so that gives me y equal root 8 for the height. So there's the height, and there's the width.